Hello everybody, let's look at a simple experiment here. We have, what are you looking at here, this breadboard. This actually analog Discover Studio basically has had the little function generator, and the function generator here you can generate the waveform here, and also you can have the oscilloscope, 2 channels you can measure the waveform. So right now I'm running this thing. Here I connected a circuit that basically replicates the example we just did. The example we did was this one here, this circuit. So I have 20 kilo ohm and 20k resistance and 10k resistance, and in this case the capacitance here, this had the impedance 1 over Cs, right? 1 over C is 10 to the power 7th. That means the capacitance is 0.1 microfarad. It's small capacitance, okay? And this little capacitance actually I'm using is what is called the electrolytic capacitance, and very small. So in this case, it's very hard to see. It's very hard to read. But this capacitance has the polarities, right? The polarity, and typically will you see this negative thing here, right? So this indicated this the negative terminal. So when you apply the voltage for the capacitor to work properly, actually the 2 legs, the 2 pins, the leads, actually one is shorter, right? The one lead is shorter, the one with the negative terminal. So you have to apply the voltage. The positive terminal has higher potential than the negative terminal. So this is different from the reference mark we use. This is actually the So the capacitance, this mark is different from the reference mark we use voltage for reference. But anyway, so I connected these correctly. So in this case, let's see the circuit, and we know the voltage here V2 is going to be higher than this voltage and the inverting terminal here, right? So therefore, I need to have the capacitance. The positive polarity terminal connected to the output. Okay, that's what I did. And for the op-amp, I used the LM324, and I brought the datasheet here. This thing has 4 op-amps inside this chip here. This chip is sitting right here, right? So this chip has 4 op-amps. So the terminals, actually it's very hard to see. I'm not that sure, but yeah, see that? Yeah, actually very hard to see. There's a notch. Typically the IC going to be, there's a notch here, and then you count the terminals counterclockwise, starting with the one on the left. So 1, 2, 3, 4, so on and so forth. That's how you count the pins for the ICs. And in any case, this one here also shows the pin. You count, there's notch on the top here on the actual chip. So this is the 1 is output, and the 2 is the inverting input, and the 3 is non-inverting input. So I'm going to use these 3. So also I supply the chip with plus minus 12 volts, and so number 4, that's the voltage, plus voltage, and this negative voltage. So I have here, if you look at the board here, I'm supplying. So here I have the voltages. So this is negative. This white one is the negative 12, and that goes to the 11 pin 11. And I have this one here. This red one coming from, this is 12 volts. Yeah, so this is 12, positive 12 volts. That goes to pin number 4. Okay. And by the way, the breadboard, all these all the 5 are shorted inside. Okay. So if I plug here, that will go to the pin 4. And that's the source I connected, and also I have 2 resistors. So this is 20K that goes from the inverting terminal. Inverting terminal is number 2, right? So the inverting terminal is number 2, I believe. Yeah. So the inverting input is number 2. So I'm connecting this number 2 to the ground. So I created a ground using the function generator here. So this is the function generator, the input to the ground. Okay, and so and also this ground is also coming from the source, right? So and so the 20K and the 10K goes between 2 and 1. So that's the inverting input to the output, and 1 is output. And this little capacitor, I will cut it because otherwise it leads too long and may short something. So I just cut it, and this capacitor here is in parallel with this 10K ohm resistance. So what I'm measuring here is there are 2 channels. What I'm observing here is, so I have 2 channels. The channel 2 I'm measuring here, this is the ground, and this is the signal. The signal actually goes to terminal 2, that's the input. So I'm monitoring the input to the waveform, the number 3. This is the number. So we are supplying the voltage at the non-inverting terminal, and so that's exactly the same. So we are supplying the voltage. So I'm measuring using channel 2, measuring the input here at the non-inverting terminal here, which is also the input voltage. I'm giving a step response, and I'm trying to use in channel 1. Let's go back to, I'm using channel 1, which is this is the ground. So I need to connect the ground and everything together. And this one goes to the terminal 1. That's the output. Okay, so that's how I connect this. Let's look at some of the waveform and see if that kind of makes sense. It took a little bit of time to set things up, but once you set up, so what I'm having here is you barely see this. Oopsies. So this is the waveform right now is running. Let me bring up to the recorded area. So in this case, I have, let's see what's going on here. So let's see the waveform generator here is the input. I have 1 volt, 10 hertz. So just the pulses. So this repeated, applying that to mimic that step input, function there, because I want a multiple. I can see on the scope, right? So if you only have 1 step, you didn't capture it, and you cannot measure. So this is the input V, and this is the output. And also remember the second channel, we are measuring the input, the channel 2, which is the blue one. The blue one here is channel 2. There's a little bit of noise on top of this. That's what we typically will see in the lab. I don't know why the position. I want to position seating at 0. So I want to change the time at 1 millisecond per division. Yeah, so this would be very similar to the one we saw in Google Colab, right? So in this case, I have a step change, and the voltage you're looking at. So now right now the axis, vertical axis shows for the channel 2. If I change that to so if you focus on the yellow one, of the kind of orange yellow for the channel 1. So this goes jump and t equal to 0 to 1 volt, and then charge to 1.05, right? So that's exactly what we observe. So this, I hope this kind of give you a little bit more experience in terms of the hardware stuff, but not this very simple circuit, of course. But you see the op-amp actually is operating right now. And I hope you enjoyed the video. Remember, no matter what you do, and keep going and never stop. See you next time.